Hi everyone, it's Katie from the Cedar Falls Public Library. I am here in our makerspace called the Collab to bring you another summer STEAM video. Today we're going to focus on the T in STEAM for technology, and we'll also be having a little bit with the A for art as well. Today we are going to be talking about sound, and we will do some different experiments, and I have a project with that as well. But first, I just wanted to explain to you a little bit about how sound works. When we speak, or when you hear music, the noise that comes out of our mouth actually sends out a vibration through the air. We can't see it or we can't feel it, but that's what happens when it comes into our ear. So I was going to show you here on my tray, I have some marbles here, and if we take a marble and we hit some of these, they hit other marbles and they move. That is a little bit about how sound vibrations work. So a sound goes out, hits another marble, hits another one, and it does like that. So when sound moves through the air, it is hitting the molecules in the air and moving through the air like so. Or if you have something else that it's moving through, we call that a conductor. Usually the air is the conductor, it moves through the air. But sound can also move through other things as well. So today we're going to have a couple experiments with sound and how it moves, and I'm going to kind of show you a little bit about that vibration. Let me get this taken care of, and then I will show you our first experiment that we are going to do with sound. For our first experiment, we are going to see a little bit on how sound moves. So we're going to see some of those vibrations that sound makes. For this experiment, what you will need is some plastic wrap. You'll need some tissue paper. I have little squares, but you can use a big sheet and just tear it up. You'll need a rubber band, and you'll need a bowl or some kind of container, and you will need a speaker. So for this experiment, we're going to take some saran wrap, enough to cover up your bowl tightly. Just going to rip that. Try to keep it as smooth as possible. I know it's hard with saran wrap. Place it on top of your bowl or container. And make sure you have some on the sides so your rubber band will go on it and hold it down. So, whoa, you might need some grown-up help with this one. Once you get your rubber band on, lift your rubber band up and pull your plastic wrap down. You want it to be snug on the top of your container or bowl. So if you lift it, your rubber band up, you can pull the plastic wrap down a little bit to try and make it tight on the surface. Next, take your tissue paper, and we're just going to crumble it up and place it on the top of our container. You can have as many pieces of tissue paper as you like. Place your bowl or container next to a speaker, and then you're going to want to play some music. And as you can see, it makes our tissue paper move around on top of our container. And you can see different parts of the song make them move a little bit more. What do you think happens if we lower the music? Let's try that. They don't move as much, do they? Let's try raising it up a little bit and see what happens. vibration, so it's sound through the air, like we did with the marbles, correct? And in this case, the music is going through the plastic wrap, that's the conductor. And so it's making those vibrations through that plastic wrap, which is what's making these pieces of tissue paper dance around on top of our container. What do you think happens if we have a slightly less, like a smoother, slower song? Let's try a slower song and see how that affects the tissue paper. So at the same volume as the one before, they are moving a little bit, but not as much as the other song. Why do you think that is? Maybe it has something to do with the instruments that they are playing with. Certain instruments have different pitches, different levels that they are playing at. This one here keeps spinning like a ballerina. Ooh, finally got one to fall off too. But it's taking it a little bit longer, isn't it? If you have different types of sound coming through, it looks like they can cause different types of vibrations in the air as well. And maybe they move differently, cause different vibrations throughout the air, or in this case our plastic wrap as our medium to go through. If you want to try this at home, all you need are these items here. If you don't have tissue paper, you could also use a Kleenex. I tested it out at my house with a Kleenex because I didn't have any tissue paper. Try it with different songs, maybe your favorite songs, see how that affects it. What happens if you have a bigger bowl? Does that make a difference? What if we move the speaker farther away? Does that make a difference in how they move? You test that at home and let me know what you find out, okay? I have another experiment that we're going to do with the sound vibrations as well. So let me get this stuff out of the way and we'll get set up for that, okay? For our next experiment with sound and vibrations, we will need some cornstarch, some water, measuring cup, a spoon, a bowl, a rubber band, plastic wrap, and we will also need a speaker. For me, I'm going to use this container to put my speaker in, and I'll explain why in a little bit. So first of all, we're going to make something called Oobleck, just kind of a substance that is sometimes solid but also liquidy. To do that, we are going to take 2 parts cornstarch to 1 part water. So I have 1 cup of water here, so I'm going to do 2 cups of cornstarch. Before we do this, kids, make sure you ask your parents' permission before you get out cornstarch. So we'll take my 1 cup here, and this might make a little mess, which is another good reason to ask your parents first before you start doing things. So remember, let's put our hands up. I need you to repeat after me. I will ask a grown-up for permission before doing science. Okay, once you do the pledge, you have to do it. All right. Oh, I'm spilling cornstarch everywhere. Out the back, out the top. That's okay, sometimes science is messy. That's about a cup. Pour that in your bowl. Okay, 2 cups of cornstarch. And a nice big mess on the table. That's okay. Like I said, sometimes science is messy. Next, we'll pour in 1 cup of water. And then we are going to mix this. little tough to mix. It's pretty liquidy still, but it seems like it is mixed pretty well. The test to know if you have it the right consistency is if you can pour it, but when you hit it, it's pretty solid. It's kind of solid. Definitely doesn't go all the way to the bottom. It might need just a little more cornstarch. And you can adjust by adding more cornstarch or more water as you need to. Okay, so what you want to do is you want to add cornstarch to this mixture until it's sort of thick. It's still kind of liquidy on the top, as you can see, but I can't, when you try to smack it, it doesn't go through. And when you scoop it, it kind of parts like that. And it's sort of, it's runny, but also kind of thick, I guess I would say. And it's kind of hard to get your spoon through it, or whatever you use to mix it. So once you have a consistency like that, get some more plastic wrap and put it over your speaker or over your container if you have to put a speaker in a container like I'm doing here. If you have a flat speaker, you can just cover your speaker in saran wrap. Unfortunately, since mine is round, it will not lay flat. So I'm putting it in this little container to help with that. Just like we did in our last experiment, make sure you pull your plastic wrap so it's nice and tight on the top here. Okay, then let's get our music going here. Let's take some of our Oobleck. Make sure you ask for a grown-up first, because this can be kind of messy. Let me get some of that gooey stuff that's on the bottom. Okay. Let's pump up our volume here. As you can see, you're going to get some of those vibrations in the Oobleck as the sound molecules go through the plastic wrap. So the sound comes up and it pushes the molecules into the plastic wrap, which makes that vibrate, and then it does the same through the Oobleck, which gives it those ripples on the top there. I'll play that again a little bit for you. Let's see what happens if we play a different song here. So this song's a little bit more mellow. You don't see those ripples on there in the same way you see the other song. So once again, like in the last experiment, it's not as moving as much. Why do you think that might happen? So if you try this experiment at home, you can play around with different songs, play your favorite songs, see how that affects the Oobleck. You can use different containers or maybe different speakers, different volume levels. Play around with it and see what your results are. See what effect it has on your Oobleck. And it could be because the different instruments and things like that have different pitches, and maybe that affects the way that it vibrates through the Oobleck. Or it could be volume levels too. If you turn it up really loud or you turn it up really quiet, how does that affect the way this moves as well? Give that a try and have lots of fun, and make sure you make some scientific notes about how the vibrations are affecting the Oobleck. I have one more project that I'm going to do with you guys, and so I'm going to clear this away, wipe up my mess, and then we'll get into that. So give me just 1 minute, okay? The last project I'm going to do with you guys today is make your own cell phone speakers. What you will need for this is 2 plastic cups, a paper towel roll, a marker, and a pair of scissors. Make sure you ask your grown-ups permission before you use scissors, because they can be dangerous and we don't want anyone to get hurt. What we're going to do is we're going to take a cup and we're going to trace the paper towel roll on the bottom of the cup here. Doesn't have to be perfect. Mine definitely is not. Then we'll take our scissors and we're going to cut the circle out. So I'm going to use this, I'm going to poke it through first. That was easier than I thought. And then we're going to cut out the circle. We'll do the same thing with our other cup. Okay, 2 holes cut out in our cups. Then you'll take your paper towel roll and we're going to need to cut a hole to put our phone in. So I'm just going to draw a line in front of the cell phone so I kind of know how long I want it to be. And be careful not to get any marker on my cell phone because cell phones are expensive. And then once again, I'll poke this through. Be careful. Make sure you have a grown-up help you with this, please. So I cut out just a small hole there for the cell phone to go through. Next, we're going to put our paper towel tubes through the holes we cut in the cup. If you want your hole you put for your cell phone to be up. And then, oh, I did not make that long enough. Okay, I have to cut a little bit more out here. Adjust your cutting as you need to. That's part of science. You try something, see if it works. If not, go back and adjust it. There we are. Now, we can play some music. Here's what it sounds like outside of the cup. Listen how good it sounds in the cups. Nice. When you put your cell phone in the speakers you made, the sound travels down the paper towel tubes to both cups, and then the shape of the cup amplifies the sound, so it makes it bigger and sound a little bit bigger. Try this at home with a paper towel tube and 2 cups, and you can listen to any kind of music, listen to your favorite songs, and you can hear a little bit better with these DIY speakers that you made yourself. After you make your speakers, you can also use the A in STEAM for art, and you can decorate these. So you can take some markers and you can color these any way you want, add some style to these awesome speakers, and then you can take them all around your house. They're pretty mobile. You can travel with them and have some great speakers to amplify all your music. That's all I have for you guys today in this week's summer steam video. Thank you so much for joining me. I hope you guys try some of these experiments in this project at home and have a lot of fun exploring the different principles of sound and how it moves. Next week I'll have another video for you in our summer steam series, so please come back and join me. Thank you so much. Have a great day. Another summer STEM video. To bring you another summer STEM video. Today we will be talking about the T in STEAM. Did I say STEM? Oh my gosh. Some water, which I don't have. What a surprise. And then it goes out and it sounds a bit more, it amplifies your sound. Okay, let's try this again. And it goes into the cups and it comes out like that. Awesome, this must be good. I think that's everything I wanted to say.